Very good evening, all my dear students. Just to let me know, am I audible and visible to all of you or not? I want to see green hearts in the chat section if I'm audible as well as visible to all of you. Let me check it out. Mark your attendance in the form of green hearts, green leaves, whatever green you are having, kids. Welcome, Wanakam, Suswagatam, Jobale Sonia, Sastrikal, Walaikum Salam, Assalamu Alaikum. This is your Baba HSP. So let me check it out. What's going on, kids? Do let me know. Am I audible and visible to all of you? Can you hear me? Can you see me? If yes, your answer is yes. Then show me green signal. Green signal. If clearly, if I'm perfectly audible, kids. Let me check it out. Let me see in the chat section that what kids are writing. What kids are writing. Good evening, Pinminbha, Ravant, Priya Pathak. Yes, that's really awesome. I want to see that how many kids are there and my voice. I would like to see that. That can you hear me perfectly? Yes, yes, fast, fast. Do let me know. Everything is perfect. Priya Pathak is writing. Everything is perfect. Let me check. Check it. Any echo is there? No echo. Everything is perfect. Fantastic. Fantastic. Sahana, just to let me know. Shubham, Chaitanya, welcome. Welcome, kids. You have to stay up to the last. Sahana, dekho dekho kaun aayi, Chaitanya aayi. That's really awesome. Call everyone, kids. Call everyone. Now, I've seen that green hearts from your side, kids. That means I'm being perfectly audible and visible to all of you. So let's go. Let's start. Let's start. Before I start this class, let me show you something. There is something for you kids. So, freedom to learn, freedom to achieve. Offer ends tonight. It's your duty to tell everyone so they can also study in the batch. Nominal price just 4,999. If they are applying the code, you know the drill kids. What's the code? Code is HSP10. HSP10 without any gap, right? So iconic, they will get just for rupees 13,999 and plus 4,999. Sharing is caring, and if you're helping others, definitely Almighty God is going to help you a lot. Will you help others, kids? Do let me know. Will you help? Yes, answer is yes. Now, one more thing is there. August 23 at 7 p.m. Notify me. What is this, kids? What is this? I'm unable to understand. ये कौन सा Pokemon है? ये कौन चित्रकार है? Just like the song, ये कौन चित्रकार है? ये कौन सा Pokemon है? Which Pokemon is this? So stay tuned for August 23 at 7 p.m. Right? There's something great is going to happen. Even I don't know what's that. So let's go with isomerism, and I will give questions after teaching you kids. So I hope that everyone is ready for the class. Now, for geometrical isomerism, if any compound like to show geometrical isomerism, what things are required and what are these type of compounds to the compounds which can show geometrical isomerism. Generally, we know that properly substituted alkene. Only the properly substituted alkene can show. So number one in our list is properly substituted. Properly substituted what? Alkene. Alkene. So in this properly substituted alkene, I will tell you this geometrical isomerism in detail. What's that? One thing is cis and trans. One thing is cis and trans. And if not cis and trans, then what? Then definitely always E and Z. What is E and what is Z? That will require CIP rule. I will tell you today each and everything in detail. CIP rule. So generally we are having this thing in our brain that properly substituted alkenes. These are the only compounds which show geometrical isomerism. But let me tell you kids, these are not the only compounds which are going to show geometrical isomerism. Along with these type of compounds, there are a number of other compounds also, those which will show geometrical isomerism. What are these compounds, kids? What are these compounds? Let me tell you about these compounds. On second number, they are cycloalkanes. These are also properly substituted and cycloalkenes. But which cycloalkane will show? That is the point, cycloalkenes. After that, I will tell you about allenes, and then I will tell you about spiranes. All these things today I will let you know in detail. So are you ready? How is the Josh? I want to see in the chat section the fire symbol. I will ask number of questions after telling you the concept. Once I will tell you the concept and then I will ask questions. Once, let me see the Josh in the form of fire. Let's start. So from compound alkenes, I am going to start from alkenes. Why alkenes shows? Because of restricted rotation. Restricted rotation. So who is the one who is giving restricted rotation? The one who is responsible for this restricted rotation. So if I draw a compound like this, carbon, 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 and here is the pi bond. Just focus. This is the pi bond. Pure p orbital, unhybridized pure p orbital. This is boundary surface diagram. And if we go away from the nucleus, the probability of finding electron will keep on decreasing. The probability of finding electron will keep on decreasing, and this overlap, very small overlap. Can you see very small overlap? This pi bond. Now, if I say kids, here we are having hydrogen, here I am having methyl, here I am having hydrogen, and here I am having methyl. So two methyls, they are on same side. Two hydrogens, they are on same side. What do you call it? Yes. Scientists, they have a compound. They call it cis form. Suppose my hands are like this. I am being the cis form. If I am rotating, there is no problem. If you rotate me, there is no problem. But if you say, keep my one hand over here, or you can say I am remaining like this and my neck is rotating 90 degree. 90 degree, it's okay. 180 degree. Neck means this nose should go that side and I should remain on this side. Is it possible? And the neck is required to be in the broken condition. Then only this is possible. Otherwise, this is not possible. So kids, if you keep this methyl on this side, And if you want to keep that methyl on that side, if you want to make compound like this, if you try to make a compound like this, that one methyl should remain on this side, another on that side. That means right now it is cis, that is trans. This was, let me write down cis over here. This is cis and that is trans, because two methyl, they are opposite side. Now, is it possible that this compound, if you rotate, if you keep it fixed, and if you try to rotate it, then this pi bond will be, it's going to break, and the breaking of bond is not good. This can't happen at room temperature. It requires energy to break the bond. It will not do this thing. Breaking of bond will not happen by itself. Are you getting my point? That means this cannot convert it into trans, and trans cannot get converted into cis. So what is the relation in between these two compounds? Definitely they are GI of each other. Suppose if I write like this, if I say that I'm being provided with two compounds, this is being cis form, my dear students, just see, this is being cis form, why cis, both the hydrogens on same side, and here if I say one methyl is on this side, another methyl is on this side, and if I say this is being transformed. So only, let me tell you, they are not structural isomer. Why? Because if I say this compound is butene, I can definitely draw this compound in this way. Just see, it is butene, and this one is also butene. The structure is same. On the first day only, very first day, I told you the structure will remain same. Only the arrangement in space will get changed. Why the arrangement in space? How can you check it out? That space arrangement is changed. See, the two methyls, these two methyls, they are on the same side. See, these two methyls, they are on the same side, but here this methyl is on this side and this methyl is on this side. They are on opposite side. And same you can talk with respect to hydrogen. So these two are GI of each other, geometrical isomers. Are you getting my point, kids? Everyone, if yes, show me green hearts that this compound and that compound, they are geometrical isomers of each other. Now, kids, what actually is required? What is the main condition that is required to show geometrical isomerism? How many of you want to know? And I will say the necessary condition required by a compound to show geometrical isomerism. Necessary condition So necessary condition, if you talk about necessary condition, kids, then I would like to say that each sp2 hybridized, each sp2 hybridized carbon must be attached with two different groups. Must be attached with two different atoms or groups. What is the meaning of this? Different atoms or groups. Sir, explain it clearly. I'm unable to understand. How to understand it? I'm not getting it. Champa is saying I'm not getting it. So let's see how to understand this thing. So if I say that these are the carbon and this is sp2 hybridized, so if I say here is A and here is also A, that means this compound will never show GI because these two are same. These two are same, so will never show GI. Whatever is written over there, irrespective of this, whatever is written, it will not show GI. Kids, are you there? Let me see the chat. Kids, do let me know in the chat you are able to understand or not. Everyone just do let me know. Am I perfectly audible and visible to all of you kids? Just do let me know, kids. Everyone, am I perfectly audible and visible to all of you? So kids, call others also, very less students. Why so less students, kids? Why students are less? Call everyone, kids. Priya, Sahana, where are other students? Do let me know what happened, kids, where the students have gone. Kids, okay, let me teach. Let me continue it. Okay, let me continue it. So, if I write compound like this, see, here I write down chlorine. Here, if I write down methyl, here, if I write down bromine, and here, if I write down ethyl. Now, do you think out of these four groups, are they same? Neither this is similar to that, nor this is similar to that. So, it can't show cis-trans isomerism, but definitely it will show GI. Will show GI. GI to definitely for sure it will show GI. GI it will show, but can't show cis and trans. So what you are able to understand, what you are getting to show GI in the form of cis and trans, at least two atoms should be same or two groups are required to be same. Right? Are you getting my point? Now this will show GI. What type of GI? It will show E and Z type. E and Z type. This compound will show E and Z type of isomerism. Now what is that? I will let you know. But before I start E and Z, let me ask question, which compound will show GI and which compound will not show GI. Are you ready for the question, kids? Everyone? Question is, which compound will show GI? Will show GI. Right? Everyone ready? Are you going to accept the challenge? Let's see. CH2 double bond CH, CH3B, CH2 double bond CH, CH double bond Cl, C, CH2 double bond CH, CH double bond CH2D, Cl, Cl double bond C, CH3, H. Do let me know your answer in the chat. Everyone, just do let me know your answer in the chat. Let me check it out. I'm sitting in front of screen. What's your answer, kids? First will not show. You are right. Sahana's answer is perfectly correct. Sahana, your answer is 100% correct. Shubham, all Shoji, I no, no, no. All, no, no, no. All is the wrong answer. Only Yashwant Reddy is right. Pin Minba is right. B. Only B will show kids. Everyone, first of all, mark the attendance in the form of smashing the like button. Why the like buttons are not smashed? Like button, you are supposed to smash the like button. Now see, only this will show. Should I explain why? Why? See, here two hydrogens are same. Can't show. Here two hydrogens are same. Can't show. Here two chlorines are same. Can't show. But here why it will show? Take it out. Hey, you just come out. Why you are able to show? Let's see. The H2 double bond CH double bond CH Cl. Now it is having two. No. I have drawn it wrong. It's double bond CH, then CH, double bond CH Cl. Now see, kids, focus over here. This double bond with respect to this double bond, two hydrogens are same. So it's dead. Can't show GI. That means, hey, my double bond is dead. That to show GI. So double bond is dead. But this double bond is dead. Now just focus on this double bond, my dear students. Just focus on this double bond. This is hydrogen and this is one big group. Both are being different. Both are being different with respect to this sp2 hybridized carbon. One is hydrogen and one, this is very big group. And if you see over here, the chlorine is different from hydrogen. So this double bond is active. So this compound is showing GI with respect to this double bond. If in your house, home, in front of God, you know, agarbatti, what do you call it? Agarbatti. What do you call in English agarbatti? Agarbatti means the aroma giving one. So if okay, let's take candle. Let's make it simple. Candle. Two candles are there. One is burning and one is turned off. Still light will be there. At least if one candle is in light position, in burning condition, light will always be coming. So if you are having 5 bulbs, all got fused except one, then light will be there because still one is there. So whenever compound is having number of double bonds, but if at least one is active to show GI, the compound will show GI. Are you getting my point? Everyone, now let's see another question. Question is, which will show GI? Which will show GI? Let's see. A. The H2 double bond CH, CH double bond CH3, C, Cl, C, Cl double bond C, CH double bond CH, CH double bond C, Cl, Cl. A. All of these. What's your answer, kids? I want to see in the chats. What's your answer? Let's see. Let me sit in front of screen and check it out. Everyone. Thank you, Islavat. Everyone, I want to see answer. Prajwal Reddy is going for 4. Incense sticks. Yes, Chaitanya, you're right. Incense sticks. I was searching for that only. Yes. D. Everyone, you're right. All they will show GI. Why, kids? This why this is the C. Here, this is dead. This one is dead, so can't show GI, but this is active. Will show GI. Yes. Here, these two are same. So this double bond is dead. Can't show GI, but here that is also dead. Can't show GI because two chlorine atoms are same. But here it is active. Will show GI. Dead. Hey, you are dead. Hey, you are dead. But you are active, so it will show GI. Everyone, till now comfortable. Now, I'm going to tell you E and Z. But before I tell you E and Z, let me tell you, if in case there are number of double bonds, and how to calculate that how many GI will be there. Ready, kids? Make a promise that everyone is ready. I want to see fire along with green hearts. Everyone, hey, everyone. I want to see fire along with green hearts. And mark your attendance in the form of kids. Pressing the like button. Hit the like button, everyone. Kids, hit the like button. Now see. Calculation for total number of GI, geometrical isomers. Now how to do that, kids? How to do that? Now see. In shortcut, I will say total number of GI, I will call it Tangi. Tangi means what, kids? Do let me know. Tangi means what? Total number of geometrical isomers. Total number of geometrical isomers. I am going to calculate. I will tell you how to calculate total number of geometrical isomers in polyvalent compound. In poly multiple bonds. Poly multiple bonds. So there will be two cases. Here we will have two cases. Case number 1 and case number 2. Case number 2 will have further two subcases. Subcase A and subcase B. Now you must be thinking about, sir, please tell us what are these two cases and then how two subcases. Ready? Ready? Everyone? Yes, sir, we are ready. So let's see case number 1. Case number 1. Ready, everyone, for the case number 1? Say yes, sir. Case number 1. Let's see how it will write. Oh, what is this? Got changed to something else. Case number 1. When terminal atoms or groups are different. Terminal atoms or groups are different. How to find out terminal atom or group is being different, kids? Baba will let you know. Their HSP sir will let you know. See, kids. But before I tell you, in this case, total number of GI will be equal to 2 raised to power n, where n is equal to number of active double bonds. Active double bonds. Kids, number of active double bonds. Now let me tell you. And remember, mark my words, kids. Categorically, I'm telling you one particular point, that whether this n is odd or it is even doesn't matter at all. Even or odd doesn't matter. Now, let me show you. Let me write on the compound. So compound, if I'm writing like this, CH3, CH, double bond CH, CH, double bond CH, and I'm writing CH. Now see, kids, focus over here. This is very, very important. It holds a hell lot of weightage. Just see. This is sp2. This is sp2. This is sp2. And this is sp2. Have you seen any movie? This is my boundary, this is my house, and this is my house boundary. No one can cross like this. So this compound is saying my boundary is from here to here. My boundary is, oh my God. Yes. Come on, come on. This is my boundary. This is my one active double bond and this is my another active double bond, and whatever is left, this is R1 and this is R2. Can you see? Whatever is the extra part, that is R1 and R2. R1 and this is R2. Can you understand, kids? No, sir. No, sir. Oh, see. It can show GI from here to here. This is one active double bond. This is another active double bond. And this is R1 and that is R2. Are you getting my point? Now, can you say R1 and R2 are same or different? R1 is not equal to R2. That means it belongs to this case when terminal atoms or groups are different. As I told you, when the terminal atoms or groups are different, then this much you are able to understand. Till now it's clear. Now it is clear. It is having two active double bonds. So total number of GI is equal to 2 raised to power 2. And that is coming out 4. 4 is the answer. You will get full marks in examination. Whether you are preparing for IIT or you are preparing for NEET, doesn't matter. You are going to get full marks in this way. Are you getting it? Till now, if it is clear, I want to see yes, green. Kids, this is the only one way, that communication method, the best way. I want to see always, whenever you are able to understand, show me anything green. Green, from distance I can see the green color. Green color I can see immediately. Watch out. Very good, Sahana. Now, kids, as I told you, formula is making our process fast, but never giving the visualization. If you really want to visualize how we are getting answer and which 4 we are having, then you have to go with HSP's visualization process. So how many of you really want to visualize which 4? So me. Okay. See, kids, this compound in this world will exist in how many forms? 4 forms. Just see which 4. First, CH3, CH, 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 Cl. What is the special thing about this compound? That this hydrogen are on the same side. So with respect to this, it is cis. This hydrogen and this hydrogen are on same side. So it is also cis. So we will say CC. We can give the name C and C. Both the 2 double bonds are cis and cis. Okay, clear? Now see the second form. CH3, CH, CH. This is cis. But this one, focus on this one. Can you see? Apply your brain, apply your eyes. This hydrogen on this side and this is on this side. They were on the same side. So this is trans. So which designation you will give? This is cis, that is trans. So CT. This is CT. Now the third one. Third one. CH3, CH, double bond CH, CH, double bond CH, Cl. Now see, who has done something bad? This has gone outside, so this is trans now. And this is cis, so its name is TC. It is TC. That was CC. And this is CT. Now what is left? Apply your brain. What is left? Which another form you can draw? Just think in a brain, kids. Fourth one, H, CH3, H, H, CH, H, Cl. It is trans at this position. because hydrogens are on opposite side, trans, and there also it is being trans. So its name designation will be TT. So these are four: TC, TT, TT, TC. How many of you got it? The visualization. All four will say to each other in the party they met, "Hey, who are you?" I'm CC. Who are you? I'm TC. Who are you? I'm TT. Who are you? I'm CT. We are 4 GIs. So total, this compound has shown 4 GI. Kids got it? Let me talk to you, kids. Yes, this is even good for CBSE board, ICC board. If you are preparing for NEET, if you want to have rank, if you are preparing for J mains, J advanced, equally good. Equally good. Priya Pathak ji, very good. Very good. You are able to understand everyone. Very good, kids. Now, let me give you one question. Let me give you one question. Question is, find out total number of geometrical isomers for this compound C. See to it. I'm giving you options. I'm sitting in front of screen just to check it out. How many of you are going to give the correct answer? Sahana, very good. Macha aaya. Wow. Medico, Priya Pathak, everyone do let me know how much you are enjoying. Kids, and hit the like button. Yeah, definitely. I will cover up all, each and everything, each and every topic. Don't worry. Very good. But A, very good. Your answer is absolutely correct. Mandy C, 8. Spinminbha, absolutely correct. Now, see, kids, either you can directly apply the formula. What's the formula? Tangi is equal to 2 raised to power n, that is equal to 2 raised to power 3, that is coming out 8. Now if you want to go with visualization, if you want to apply visualization, then what are these 8s? This, right? Trans, because 3 double bonds active. Now CCT, then TTC, then CTT, then TCC, then CTC, then TCT. See, is there anyone repeated? One random, mono, nale, anche, are, ere, actor. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Just check it out, kids. Whether you got it, whether you are able to understand or not. It is clear the visualization as well as with the help of formula. I hope that everyone got it. If you really enjoyed it, once again, I want to see green, go green, kids. Now, case number 2. Are you ready for case number 2, everyone? Is everyone, kids? Do let me know. Is everyone ready for case number 2? Dana, yes. Dana, yes, kids. This case is when terminal atoms or groups are same. Remember, mark my words. When terminal atoms or groups are same. Now, how will you find out that terminal atoms or groups are same? Just see, focus over here. Now, first write down Tangi. What is Tangi? Total number of GI. If you have joined right now, let me tell you right now, I'm telling you geometrical isomerism. Tangi means total number of GI. That is equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1. This will be your formula. 2 raised to power n minus 1 and 2 raised to power p minus 1. Now, how to find out what's the value of his being p? What is p? How to get it? Now, sequence. Subcase A and subcase B. Subcase A and subcase B. Here, value of n is equal to even. Here, value of n is equal to odd. It can be. There are two cases. In the first case, whether even or odd, this was same. The formula was not changed, but here the formula will change. P. Here the value of P will be, it's even. So n by 2, and there it's odd. So P is equal to n plus 1 by 2. Now let's apply. If I write down the compound H3 CH double bond CH double bond CH and CH3. Now see, if I say it is showing Pi from here to here, now what is left? This alkyl group is left. This is methyl, this is R1, this is R2. R1 and R2 are being same. Yes, sir. R1 is equal to R2. This is methyl. That is also methyl, and number of double bonds are being even. We will apply this formula. And if I write down here, a compound like this, CH3, CH double bond CH, CH double bond CH, CH double bond CH and CH3. It is showing GI from here to here. And if I say this is R1 and this is R2, this is R1 and that is R2, they are also same. But number of double bonds 1, 2, 3, they are odd and these are even. Sir, we are not able to understand. Tell us in detail. So how many of you want this in detail? Okay, let me tell you, let me explain these two cases on the next page. Let me. First, subcase A. CH3, CH double bond CH, CH double bond CH, CH3. Just see, from here to there, double bond. That means this is the boundary. sp2, how to find out the boundary? sp2 and sp2. Now see, this is R1 and this is R2. They are same or not? R1 is equal to R2 or not? So this is case number 2. First of all, you have to find out whether this is the case number 1 or case number 2. Once you got it, is case 2. Now see, double bonds, the value of n is equal to 2, that is being even. So apply the formula, total number of GI 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is equal to what? 2 raised to power n minus 1, 2 raised to power p is equal to n by 2 minus 1. So what is the value of n? N is equal to 2. 2 raised to power 2 minus 1 plus 2 raised to power 2 by 2 minus 1. So 2 raised to power 2 minus 1, 1. 2 power 1 is 2. and 2 raised to power 2 by 2 is 1, 1 minus 1, 0, 2 power 0, anything power 0 is 1. So total answer is coming out 3. Got it, kids? Now, how many of you want to see the visualization? Do let me know in the chat section if you want visualization. So let me give you the visualization for this compound. See, kids. If I write CH3, both the two hydrogens are on same side, cis. Both the two hydrogens are on same side, cis. So its name is CC. Now if I draw a compound like this, if you see with respect to this, hydrogens opposite trans, so its name is TT. These two are different. So I will say this is first, this is being second. Now let me draw the third one. It is cis, that is trans. Fourth one, if I draw, I would like to say this is trans and this is being cis. Now check it out, third and fourth are same or different? Do let me know. These two are same or different? Please, kids. Please do let me know. These third and fourth one are same or different? See, because this side methyl and that side also methyl. So this is cis, that is trans, or this is trans, this is cis. If you flip it, this compound and this compound, they are being same. These two are same. So we will say that we will count them to be one only, one. So 1, 2, and these are being same. Third is equal to 4. So we will take them as a one compound. Let me know in the chat section, kids, if you got it. बाबा कितनी आवर्स की क्लास? ओ माय गॉड, सहाना वेरी गुड हिंदी. 90 minutes class, just 40 minutes more. Sahana, 40 minutes more. Okay, let me see, kids. I will teach you each and everything, right? Sahana, क्या हिंदी लिखी है? Wow, मस्त हिंदी. That's really awesome. It's Sahana. Kids, show me green hearts if you are able to understand. Hey, bacha. Everyone, do let me know. Now subcase B. Subcase B. Odd number. Let's say CH3, CH, double bond CH, CH, double bond CH, CH, double bond CH, and CH3. From here to here, we are having 1, 2, 3. 3, n value is 3, and this R1 is equal to R2, right? R1 is equal to R2, so terminal are being same. So Tangi is equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1, right? So 2 raised to power 3 minus 1 plus 2 raised to power 3 plus 1 divided by 2 minus 1. So 2 raised to power 2 minus 1, 2 raised to power 2, 4 plus 4 by 2, 2 minus 1. So 2 raised to power 1. So 4 plus 2 is 6. 6 is the answer. Got it, kids? Do let me know everyone got it or not. Hey, bacha. Awesome. Hindi Sahana. Yeah. Yes. Now see, kids. Everyone is able to understand or not? Just to let me know. Just to let me know, kids. Everyone, do let me know. Fast. I want to see your answers. Kids, do let me know. Fast, kids, fast. Now, everything is clear. Now see, kids. E and Z. E stands for antigagen. And Z stands for Juicer-man. Juicer-man. Which man? Juicer-man. Juicer-man. Antigagen and Juicer-man. Everyone ready to find out E and Z? Let's see. If I say C double bond C and the compound is given like bromine, hydrogen, Cl, and what to say? Anything you can write CH3. Now, how to find out? It will not show cis and trans. Are you getting my point? Can't show cis and trans. Why? So why? Because all four are being different, but it will show GI. But will show GI. Why? Because its double bond is active. Why it is active, sir? How to find out? This is sp2, this and this being different, and that and this being different. This is different from this, so we'll show GI. Now this is E or Z. We have to find out whether it is E or Z. For this we have to understand the CIP rule. 3 scientists. Scientist number 1, ding ding ding. Scientist number 2, ding ding ding. Scientist number 3, ding ding ding. 3 scientists, they have given rule. One scientist name was Kahan in gold. Log. Now no need to remember the names. Just take C from here, I from here, and P from there. CIP rule. We have to understand CIP rule. Nice drawing, kids. Nice drawing or not? We have to understand CIP rule, and this rule will help you a lot in understanding your what? Chiral racemization, everything, RNS system, capital D, capital L, that is optical isomerism. You can easily trace about optical isomerism if you can get this CIP rule. What is this rule? Rule number 1, rule number 1. Yeah, rule number 1, baby number 1, rule number 1. CIP rule. We are going to understand the CIP rule. Are you ready? Everyone, are you ready? CIP rule, la la la. We are going to understand. La la la. La la la. CIP rule, CIP rule, CIP rule. Rule number one, rule number one, rule number one. Are you ready? The atom directly attached. Directly, which atom we have to see? We have to focus. Which atom we have to see? We have to put eagle eye on that atom. The atom directly attached with sp2 hybridized. Can you understand, kids? The atom, this atom, with maximum atomic number, with maximum atomic number, will be senior most. Kids, will be senior most. We don't know atomic number, then how to get it? We don't know atomic numbers, sir. Then how can we find it out? Are kids, don't cry. I will tell you the technique. You must have seen the periodic table, like carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, like this. So as you move, kids, hey kids, if you go from left to right, atomic number is increasing. Hey bacha, you let me know. If you go like this, atomic number is increasing. If you go like this, atomic number is increasing. That's it. Nothing to do. No need to cram the atomic number. Just think like this. Everything is easy peasy, lemon squeezy. You can understand everything, kids. Now see. Let me give you one compound. The same one. Wow. Sir, it's looking easy. Dun, dun, dun. Let me give you one compound. See. Double bond C. Hydrogen. Chlorine. Bromine. Iodine. Now just see this right hand side. When you're focusing on right hand side, you have to focus over here. Now we are having two atoms. Same thing. Who is senior? Do let me know in the chat section. Who's senior? Sir, chlorine. Okay, right. Now see over here, bromine and iodine. Who's senior? Iodine. Now height. This is like a river. River is flowing. River is flowing. River, consider it like river. Now both the seniors are on same side of river or not? Both the seniors are living on the same side of the river. So we will say it is Z. Z means Jodi. The same side means Z. Got it? Okay, got it. Now by chance if the compound was given like this, C double bond C, hydrogen, hydrogen, chlorine, chlorine. Now this is cis. We got easily this is cis, kids, because the same hydrogens are on same side. Right? Now, whenever any compound is showing cis and trans, definitely it will show E and Z. If a compound is not showing cis and trans, just no, not to worry about it. It will show E and Z. That means if any compound is showing geometrical isomerism, then one thing is must, that it has to show E and Z. So not able to understand. I'm saying that if a compound is showing geometrical isomerism, then one thing is for sure, it will show E and Z. Definitely, whether cis trans is defined or not. Now see, let me explain. It is cis. Now, if I want to write out E and Z in this, out of these two, this is senior. These two in between, these two, this is senior. So senior are being on same side. So what is this? Z. Z isomer. Z configuration. So it is both cis as well as Z. No, sir, I'm too unable to understand. Okay, don't worry, don't cry, kids. Let me tell you. If I say, do you know these two compounds? This is cis, that is trans. You know very well from the beginning. These two hydrogens are on same side, so cis. These two are on opposite side, so this is trans. This you know very well. Don't cry, kids, don't cry. This is cis and that is trans. This you know very well or not? Do you know? Yes, sir. Now see, if I try to find out E and Z, this is carbon, this is hydrogen. Who is senior, carbon or hydrogen? Carbon is senior. In this, carbon is senior. So senior and senior are on same side. So Z, cis, either you say cis or you say Z configuration. It is having two names. This compound is having two names. Either you can call it to be cis or you can say you are Z. There is one person, but one person can have two names. I can call Mr. X, and Mr. X mother is saying, "Hey Chotu, come here, my dear Kutu Chotu, my dear," or Anna, come here, like that. Okay. Now, in this is senior, and here this is senior. They are opposite. So E, you can correlate E to be opposite, like enemy. You can say like enemy, E to be enemy. They are on opposite side. Are you getting my point, kids? Everyone clear? This was CIP rule number 1. If it is clear, I want to see green hearts. Priya Pathak, very good. I can see your name from here. If it is clear, kids, I want to see green hearts. Just to let me know it is clear or not, kids. Everyone, clear. Sahana, very good. Wow, K104, K2 M104, you got it. Very good. Now, see, PIP rule number 2. Ready? PIP rule number 2. If first atom is same, then see the second atom and which second atom? Most senior one. Most senior one. For priority order. For priority order. For example, just see, if I write down one compound like this, this is fantastic example, fantastic, very awesome example, kids. Just see, if I compare the right one, this right carbon, if I see this right carbon, the first carbon to this carbon, sp2 hybridized carbon, the attached carbon is this carbon is only carbon, atomic number 6. This is also carbon, both are carbon. Can you see? This is carbon, this is carbon. Both carbons are same, so they are unable to decide. Are you getting my point? Unable to decide. Once the first atom is unable to decide, then see the second atom. Which atom? Senior most. Its senior most atom is chlorine and its senior most atom is oxygen. Chlorine's atomic number, I don't know. I will not say I know that 17. I don't know. No need to understand. But chlorine belongs to third period. Chlorine, and oxygen belongs to second period. Who will be senior? Do let me know in the chat section. Definitely, chlorine is senior. So, this is senior. Same, come over here. This is iodine, but don't see iodine. Just see the direct atom attached. This is chlorine, and direct atom attached. This is carbon. Definitely, chlorine is senior. It's this much. You got it or not? Senior are on same side. I will say it is Z configuration. This is being Z configuration. Cis and trans is not defined. Cis and trans is not defined. Not defined. Not defined. It's to let me know how many of you got it. I'm going to sit in front of the screen, kids. Wow, thank you, Wi-Fi. Juice man, very good. Wow, kids, you're enjoying. Super hit Priya Patak. Kids, do let me know. Really, I'm doing a hard work or not for you, kids. Wi-Fi and everyone, Bhavani, welcome. Kids, do let me know. Really, I'm doing a hard work or not for you, kids. Bhavani, very good. Jyoti, oh my God, my kids are there. Everyone, I'm really thanking to God that my kids they have not forgotten me. Wow. Oh, Wi-Fi, you are new to this channel. Are you new? Wi-Fi, are you new? Wow, Sahana, thank you. Wow, wow, wow. Now CIP rule number 3. Are you ready for CIP rule number 3? Now let me tell you CIP rule number 3, kids, right? Everyone, I'm going to deal with CIP rule number 3. Just see. In case of isotopes, in case of isotopes, in case of isotopes, more is the mass, more will be seniority. More the mass, more will be seniority. Right? For example, if I write down compound like this, C double bond C, H, E, CH3 and Cl. Just see. You know isotopes. If I say hydrogen is protium atomic number 1, mass 1. Deuterium atomic number 1, mass 2. Tritium atomic number 1, mass 3. These are isotopes having same atomic number but different mass. If I write down carbon 6, 12, carbon 6, 13, carbon 6, 14. They are also isotopes. Now see kids. If I say the right hand one, sp2 hybridized carbon is directly attached to this carbon and this is chlorine. This is senior, no problem. But here these are the isotopes, so this is senior. This one is senior. Got it? So they are the senior are on same side. So Jusaman jet configuration. Everyone got it? Now let me give you one for you kids if you are able to understand. Tell me. Now I'm changing the orientation. I have drawn river like moving north to south. Carbon CH3, CH3, 14. Simply CH3. If nothing is written, that means it is 12. Deuterium and hydrogen. Tell me. I'm waiting for your answer. Just to let me know. E or Z? Wow, thank you, Sana, for your efforts. I'm so much glad. Everyone, do let me know what's the answer. Sahana is the first one to give the answer. Let me check. Kids, others to let me know and hit the like button, kids, if you're really enjoying it. If you're really enjoying the lecture. Thank you, Priyaji. Thank you. Now let me check it out whether the answer is right or wrong. Out of this is senior. It is having more mass, and this is having more mass. So Z, just a man. Very good, kids. Now I'm going to deal with CIP rule number 4. This is tough. Will you go with the tough one? CIP rule number 4. This is the toughest one. Would you like to go with this? In case of multiple bonds, we have to draw hypothetical structures. Now, kids, this one is the toughest one. If they are going to ask such type of question in the examination, maximum people are going to get failed. Maximum people, definitely maximum people will get failed. See how to draw hypothetical structure. Suppose if they have given question like this. CHO, COOH, CH, NH2, 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 and CN. Now this compound definitely will give negative marks to maximum of the people. Then everyone will say, oh, NTA has given very tough paper. Now this is really toughest one, right? Now we should know how to draw the hypothetical. So let me write down. If I write down CHO, it's first write down it properly. That's CH double bond O. This much you can write, or you can write it like this, no problem. Anyways, you can write double bond O. Just try to understand. There is one sigma bond and there is one pi bond. Do you know this much? Able to understand this thing, you can write. See, all the sigma bonds I will write in the same way, the way they were written. This sigma bond, all the sigma bonds I have written properly as they were earlier written. Now I have broken down what I have broken down. Broken down pi bond. See, I have broken down pi bond or not? Can you see it's broken down pi bond? Can you see kids? I have broken down pi bond. Now, the pi bond which I have broken down was really attached with whom? The pi bond was attached with carbon as well as it was attached with oxygen. So carbon is shouting, hey, you have broken down my pi bond. I was connected with carbon's pi bond was connected with oxygen. I said, hey, I've given you oxygen. Now oxygen started crying, hey, you have broken down my pi bond. I was connected with carbon. So I said, oh, I've given you carbon. Now are you happy? Sir, not able to understand. Tell us once again. Okay, let me explain another one. See, let me take another one. COOH. Don't consider it to be a group. See, write down properly. C double bond O OH. Sigma bond I will write down as such. Sigma, 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 sigma I will draw, but pi I have to break. Now see, carbon, oxygen, oxygen, hydrogen. All the sigma ones I have written like as they were written properly. Already as they were written, I have written or not, kids? I have written or not, kids? Do let me know. Do let me know, kids. Now see, I have broken down pi 1 from carbon. Carbon was attached with pi 1. I have broken down an oxygen. So what I am supposed to do? I will write this carbon with oxygen and oxygen with carbon. So these are hypothetical structures. Hypothetical structures. Got it, kids? Everyone? Have you got it? Now I will write down for cyanide also. I will write down for cyanide also. See, cyanide I know this, but write down properly. Actually, cyanide is like this. How many pi bonds? One sigma, anyone to be sigma. Let's say this is sigma. Those two are pi, 2 pi. So how to draw hypothetical structure? Sigma bond I will write down like this. Now pi bonds, I'm supposed to break the pi bonds. Now it is attached with two pi bonds. So I will say, hey, I've broken down a pi. Hey, I've broken down a pi. Carbon will start crying. What carbon will say? You have broken down my two pi bonds. I was attached with whom? He was attached with nitrogen. Say, I have given nitrogen. I actually converted pi bonds to be sigma bonds. What actually I'm doing? What actually I'm doing? I'm converting pi bonds into sigma bond. The attachment is remaining same. Am I right or not? I'm just what I'm doing. What I'm doing? I'm converting pi into sigma. That's it. And nitrogen I have given carbon. Am I right, kids? Am I right? Now, now see this compound. Here, this is sp2 hybridized, and this carbon is attached with this carbon. This carbon and this carbon is same, and this carbon is saying, hey, I'm attached with two nitrogens. This carbon is shouting, I'm attached with two nitrogens, and he's saying, hey, you are attached only with one nitrogen. Upper carbon is saying to the lower carbon that I'm attached with two nitrogens, but you are attached with one nitrogen. But he will say, hey, it's looking like this. Actually, my structure is not like this. I'm actually attached with how many nitrogens? One, two, and three. It's looking one nitrogen, but actually it is this carbon is attached with three nitrogens. Are you getting my point, kids? If yes, I want to see in the chat section. Yeah, I will give question, Jyoti. Let me first explain, then I will give you number of questions. First, you are able to understand that cyanide is looking in the first step that it is attached with only one nitrogen, but actually it is attached with three nitrogens. So it is a winner, and we'll say you are the senior most. You are not looking like senior, but actually you're being the senior. Your nitrogens are being hidden. If pi bonds are there, we have to consider that. Yes. It's do let me know. You are able to understand or not? अच्छा अच्छा Chaitanya, question दूंगा, but if you are able to get it, show me green hearts. Now see, so actually this is senior. Winner, you are senior. And there, this is attached with one looking like one but two, and it is looking like two but three. This is senior. Chat configuration. Everyone got it? Now I'm going to give you questions based on question number one. Yes, tell me, kids. What's the answer for this compound? Tell me, kids. I'm waiting for your answer. Yes, kids. E. Sahana is going with E. Anushri, E. Savati. Okay, let me check it out. This is sp2, right? This is directly attached. It's saying I'm carbon, but its nearest is oxygen, but it's carbon and carbon. So this is declared to be senior. Everyone got it senior. Now here, carbon. I'm also carbon, but I'm attached with two oxygens. They are a carbon only, senior. So senior are on opposite sides. So E configuration. Winners, clap for yourself. Clap. Ready for another question? Everyone ready for another question? And you ready for another question? See, carbon, cyanide, chlorine, OOH, OH. You let me know. E or Z? I'm waiting for your answer. I'm waiting for your answer. Fast, fast. Okay, everyone is going with E. Sahana has written E. So out of these, this is senior. Out of these, this is senior. You have considered it to be IUPAC. Don't take it as a group. I told you to see atom. Here cyanide and this is chlorine. More atomic number. Are you getting my point? More atomic number. And here this is carbon. Just see, this is carbon and this is oxygen. More atomic number. Kids, this is a question where maximum people are getting failed. Same side, so it is Z configuration. Sahana, you got your mistake. You got your mistake. Okay, Z. Okay, changed. Okay, you have changed. Okay, okay, good, good, good. Now CIT rule number 5. Everyone ready for CIT rule number 5? Bond pair is senior to lone pair. Bond pair is senior to lone pair. What is this? Let's see. If I say CH3, CH, double bond NOH and H. No, no, no. Lone pair, lone pair, lone pair, lone pair. Now you know as it's syn acetyldoxime. You must have seen syn acetyldoxime in GI. People call it syn. But if you talk about E and Z, out of this, this is senior and this is a lone pair and this is bond pair. A bond pair is senior. This is senior, that is senior. Senior, senior, opposite side. So I will say this is E configuration. Everyone, all the rules you are able to understand. This much is clear to each and everyone. Just to let me know. Now I'm going to tell you GI in cycloalkanes. Are you ready? GI in cycloalkanes. Everyone, are you ready, kids? Do let me know. Okay, let me see what Sahana has writing. But yes, Baba, I have to answer correctly at the first time only. I select. Okay, okay, no, no problem, Sahana, no problem. Now, kids, are you ready for GI in cycloalkane, then cycloalkene, and then alene? Then it will get completed, kids. Class till 8:30. 8, I think it will take 8:45. It will go up to 8:45. Okay. because it will require some time. Very good. See, kids. in geometrical isomerism in substituted cycloalkanes. Just see, if I say that I'm provided with cyclobutane and cyclobutane is planar. If I say that this is cyclobutane, if I say this is cyclobutane, and if I put one methyl up and one methyl up, then they are on same side. See, cyclobutane, dimethyl cyclobutane. Or if I put it like this, then also same side. If I put it like this, downside, then also same side. Cis. But if one I draw on downward side and another one upside, one is going up, one is going down, opposite trans. So let me draw it over here. One form is this, and another one, let me draw like this. So see, kids, CH3, H, CH3, H, both are going up and up, same side or not? Same side, so cis. And now if I place one CH3 up and one CH3 down, this is up, this is going down, so trans. I hope you got it. One is being cis, another one is trans. So what's the relation they are holding? They are GI of each other. Got it? Everyone got it? Yes. Now, if the same thing I draw in cyclohexane, just see, focus. If I draw in cyclohexane, this is your cyclohexane. And if I draw it like this, CH3, this is cis. Both are going on the right hand side. Or I could have drawn it like this, coming towards observer side, towards your side one methyl, and this methyl is also coming towards observer side, towards your side. This is also cis. Or I could have drawn like this, going up. This is also cis. Or I could have drawn like this, going down. This is also cis. All they are identical. All of them are identical. But you will not be able to understand if I would have drawn it like this, the chair form. If I would have drawn like this, and if I say the one methyl is going in axial position and one methyl is coming equatorial position, this is also cis. Now this is tough to understand. They all are identical. All are identical. Which one you are not able to understand? Do let me know. They all are being identical. Which form you are unable to understand? Do let me know out of these. Definitely you will say this one, how this one is cis. How this one is cis. Just tell us, kids. Right? Want to understand? Let me tell you. Let me tell you. Draw the chair form. Everyone see this is chair form. It's looking like chair or not? Do let me know. It's looking like chair, right? Now see, three vertices are going up and three vertices are going down. Can you see? Three vertices are going up and three are going down. This is the chair form of cyclohexane. Do let me know. Are you getting my point? Now see, if the vertex is going up, try to understand. If the vertex is going up, then its axial will go up and equatorial will go down. Just see, if vertex is going up, if vertex is going up, then axial one is up, then equatorial one will be down. Equatorial will be down, right? Now if vertex is going down, then axial one is going down and equatorial one will go up. So hydrogen is going down and methyl is going up. Just try to understand and focus on methyl. 2-methyl. 1-methyl is going where? This methyl is going up and this methyl is also going up. Both the 2 methyls are up. Both methyl are up. So same side. So cis. How many of you are able to understand this one? Do let me know. Then only we can do rank deciding question. Very good, Sahana. Now, if you are really able to understand this chair form, then I can tell you this cis and trans, because this tough question can be asked, because NTA has shown this time the physics paper was tough. How they can create a tough paper, kids. Everyone, now see. If I say that I'm writing this and this. Now everyone can understand very clearly that if I have drawn two methyls like this is cis, and if I'm drawing two methyls like this, then this is trans. This everyone can understand, right? Now, but focus over here. What I'm going to tell you. Now, this one is tough part to understand. See, I'm writing this methyl is going like this, hydrogen like this, hydrogen like this, methyl like this, and here I'm making one methyl is going like this, hydrogen like this, and one methyl is going like this, and hydrogen going like this. This and this are cis. Both of these are being cis, and both of them are being trans. How many of you are able to understand that that side one are trans and this side one are cis? How many of you are really able to understand? Do let me know, kids. These two are identical, those two are identical, but this side one and those side one are GI of each other. How many of you are really getting it? Do let me know, kids. Then I will tell you. If you are not able to understand, I will tell you kids. Don't worry. Don't cry. I will tell you kids. Do let me know in the chat section how many of you are really able to understand. Do let me know kids. Sahana is able to understand. First one cis and second one trans. Wow. Do let me know kids. Oh my God, Sahana, thank you. Priya Patak, very good. Now, kids, do let me know how many of you are really able to understand. Now, let me explain it. Let me explain it. See, this rocket is going up. You see, this vortex is going up one, then the axial is up. This equatorial is down. This rocket is going down. This rocket is going down. So its axial is going down. If axial is going down, then equatorial is going up. Now see, two methyls are up. This is up and this is up. Same side. So cis. Now here, this rocket is going up. So its axial is going up. This methyl is going up. And this rocket is going down. So this axial is also going down. So two methyl groups, one is up, another one is down, opposite. So it's trans. This I wanted to tell you, kids. This I wanted to tell you. Now let me give one question. Let me give one question. Let's see how many of you can do it. Find out relation in between A and B. Chlorine going up, hydrogen going down. Chlorine going up, hydrogen going down. This is A. Chlorine going up, hydrogen going down. Hydrogen going up, chlorine going down. Yes, what's the answer? A and B are what? Let me know. I'm sitting in front of screen and waiting for your answer. Chaitanya, no class after this. But I will try, I will definitely complete it at before 9. Before 9, I will complete this class with all the questions and everything. Chaitanya is going for B. No, Chaitanya question is find relation in between A and B. What's the relation? What's the relation in between A and B? Fast, kids, fast. Do let me know, fast. Fast, kids, fast. A is cis, yes. Uday, you're right. A is cis and B is trans. But relation, these are the names. That this is being cis. Both the chlorine are going up, same side, up and up, same side. Cis. But this is the name of this compound, cis. This one is going up, this one is going down, this trans. What is the relation? What is the relation? Now, its answer is its position. Just see the position. It is 1, 2, 3. 1, 3 dichlorocyclobutane. And that is 1, 2 dichloro cyclobutane, right? Their structure is different, and once the structure is different, they will be known as structural isomer. Their position isomer. Very good. Their structure is being different. Structural isomers. And once we are having structural isomer, they can't be GI. They are actually position isomers. So if the structure is different, then cis and trans can't be geometrical isomer. Mark my words, categorically I'm telling you this particular point, that if they are structural isomers, they can never be geometrical isomers. Got it? Got it. Now the last one. See what I'm going to tell you. GI in cycloalkenes. Everyone ready? Everyone ready, kids? GI in what? GI in cycloalkenes. Cycloalkenes up to 7-membered can't show GI with respect to double bond. Now question arises, why? Why so? Because they exist only in cis form. Actually, the trans form does not exist. If I say I'm only the one son of my father, I don't have any brother, then is there anyone I can say you are my brother? There will be no brother, right? So question arises, why so? Why so? If I say I'm having cyclobutane, then it cannot exist in trans form because of ring strain. In trans, it will have ring strain, so it will not show GI. Now kids, they will exist only in cis form. If I say cyclohexene, then it will exist in cis form only. How will you say it is cis form? How to find out it is cis form? See, this is sp2 hybridized carbon. One bond is going toward this side, so definitely hydrogen will be on that side. This bond is going toward this side, so hydrogen will be on this side. They are on the same side, so let's try to understand. Now, what I'm going to tell you, cycloalkenes. The second point, if I would like to say second points, cycloalkenes of 8 carbon or more, 8 carbon or more, will show GI with respect to double bond. Why so? Now, once the number of carbons are increasing, so if I say cyclooctane, cyclooctane can be like this. What is this? Cyclooctane. If I make cyclooctane, it can be in cis form and it can exist in trans form as well. See how to find out cis and trans. See where the double bond is there. This is going in this direction. You know, double bond is trigonal planar sp2 hybridized. So 120 degree it has to move. It is going this side, so hydrogen will go this side. This. And cycloalkane over here, this bond is going that side, so it will hydrogen will move on this side. This is going this side, hydrogen will go transform. So what's the relation they are holding? They are GI of each other. Are you getting my point? Everyone. If you're really able to understand, I will give you one question, and then that question will explain what actually I am trying to tell you. Just see the question. Which one will show? Yeah, very, very good question. Mind-blowing question. Try to understand what I'm going to tell you. A, B, C. D. What's your answer? What's your answer, kids? I will take 10 minutes more. After this, only one topic. Two topics. Very, very small topics. Are wah, Chaitanya. Yes, yes, yes. Priya is thinking for B. Rest of the other students, do let me know. Yes, kids. Now see, kids. Here you are taking too much time. That means this question is tough. Definitely it is tough. Jyoti is also going for B. Priyaji is also going for B. Now let me explain, kids. See, B is wrong answer. B is wrong answer. See, correct answer is this one. If this double bond is dead, can't show GI, it will always exist in cis form only. Only cis. This double bond is dead. This will also only exist in cis only. This double bond is also dead. Will exist cis only. This double bond is also dead. This will exist in cis only. Then why this is the correct answer? C. It will show GI with respect to these two methyls. C. Once two methyls will remain same side, and once one methyl is on this side, another methyl is on this side. So it has not shown GI with respect to double bond. It actually has shown GI with respect to these two methyls. That is properly substituted cycloalkane. Properly substituted cycloalkane. Got it? Everyone, is it clear? Is it clear, kids? Then show me green hearts. Now, allenes. GI in allenes. GI in allenes. 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 Now, two conditions are required. Condition number one, that is same as I told you earlier, each sp2 hybridized carbon must be attached with what? Carbon must be attached with different atoms or groups. And second condition. What's the second condition, kids? Number of pi bonds must be odd. Must be odd. Now, if you can't remember that pi bonds should be odd or even, then I'm going to give you one trick. HSP Baba's trick. HSP trick. Whenever you are not able to understand anything, remember God. God. Remember God. Just remember God. See, God is made up of three letters. Tricolor God. To show GI, number of pi bonds must be odd. To show GI, number of pi bonds must be odd. Odd. How's the trick, kids? Now let me show you. Now see. Everyone just see. One pi bond, one more pi bond, one more pi bond. Three pi bonds, that is odd. Now, you must be thinking, sir, why it's like that? Why it's like that? Why it can't be even? Let me tell you. If I say this valency is coming towards your side, if I say this valency is coming towards your side, and it is, let us suppose it is horizontal. Let me say it is horizontal. Okay, let me suppose it is horizontal. Okay, kids, it's horizontal, then definitely this is going away from you, but it is also horizontal. Both are being horizontal, right, kids? It's being horizontal, and that is one horizontal. Horizontal, right? And that is also horizontal, right, kids? The red one is horizontal, and this is also horizontal. Then pi want, you know that sigma and pi, they are perpendicular to each other. If I say this is sigma, then this 90 degree will be the pi bond. Pi bond will be 90 degrees. So I will say this pi bond will go 90 degree to it. That is perpendicular to the plane of paper. This pi bond, I am writing this pi bond, and it is forming a pi bond with this. So it has to be 90 degree, right, kids? They are vertical. I will say these two pi bonds will be definitely vertical. Let me write down, it's vertical. Pi bond is vertical. This pi bond is vertical pi bond. Okay. If I say this is being vertical pi bond, it's any doubt till now? Any doubt to anyone? Vertical. Now, it is attached with one more pi bond, so definitely this is vertical, then that will be horizontal. This red one will be horizontal, kids, so it will be horizontal. Take with this, it has to be horizontal. So how it should be? If I say if one pi bond is going vertical, another pi bond has to come like this horizontal. Are you getting my point? Like this, like this. No, you're not able to understand. I will say like this. If 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 this is sigma bond, if I say this is sigma and this is one pi bond, the white one is one pi bond, then another pi bond will go like this, perpendicular to them. Are you getting my point? So this is once again horizontal. This red one will once again horizontal, horizontal, right? This red one is horizontal. Then it is attached with one more pi bond. This has to be vertical. This has to go vertical, vertical. So it has to go vertical, vertical. And once it is being vertical, the sigma bonds once again will come horizontal. Horizontal, the sigma bonds once again will come horizontal. This is coming towards observer side, and this is going away from observer, but horizontal, right? So see what I want to say, that this R2 and this Y, they are in same plane. R2, Y, X and R1, they all are in same plane. They all are in same plane. Can you get it, kids? And they have to be in same plane. R1, R2, X and Y, all they are in same plane, and that is required. All they are required in same plane. Are you able to understand this thing? And that's why it is required, kids, just to let me know. I've tried my level best to show you the chemical bonding and each and everything. Have you got it? Are you able to understand or not? Kids, do let me know. I tried my level best. How the bonding is appearing, just do let me know it's looking good or not. You are able to understand. Okay, Saka, you are unable to understand it. Okay, let me explain it. Don't worry, don't no need to worry. Let me explain it. Don't worry, don't worry. Just see, tell you on another page. Just if I say that I'm provided with, I'm making one plane. I'm trying to make one plane. Just see, suppose if I say this is bed, if I say this is being bed, bed, you know, if I say this is bed, bed, you know, it's, if I say this is bed, just see if I say this is bed. If I say this is bed, you understand bed is planar. Can you understand bed is planar? That you understand. This is bed, bed. Suppose this is bed. And on this bed, let me draw one carbon, second carbon, third carbon, fourth carbon, 1 pi, 2 pi, 3 pi, right? 3 pi I have drawn. Okay. Now if I say hydrogen is coming towards your side and it is on bed, right? If I say this is hydrogen and it is on bed, I say horizontal, it is on bed. This is hydrogen atom and it is on bed, right? And this is methyl, or I say chlorine, this is also on bed. Now this is horizontal. If I say it is horizontal, that is also horizontal, that is on bed, then the pi bond will go. Pi bond will go vertically up. Above the bed, it will go above the bed and it will go downside of the bed. Am I right? And to form a bond with this, has to go above the bed and below the bed, and they have formed one pi bond, pi bond. Now another pi bond will come on bed only. It is sleeping on bed. This pi bond, this pi orbital and this pi orbital, they are on bed only, horizontal. They are forming a bond. Now another, this will go above the bed and this will go down the bed, above the bed and down the bed. Now vertical, vertical. Let me write down vertical, horizontal, vertical. So sigma bond once again will come on the bed only. This hydrogen will come on the bed and this methyl will also be on bed. Now hydrogen and hydrogen, both the hydrogens are on bed or not? They are on same side, so we'll say it is cis. Got it? Both the two hydrogens are on the bed only. So this will show Gi once same side, another side. This hydrogen will go on that side. It will be trans. Now you are able to understand. Do let me know in the chat who said that you are unable to understand. Thank you, Pinminba. Thank you. Priya Pathak. Thank you. Wow. Thank you, kids. Now try to understand that you got it. Everyone just to let me know. Thank you, Sahana. Thank you. Wow, Islavat. Thank you. Kids, you have to tell everyone that really Baba is hardworking. Now, only the last one I have to tell you, and then sin and anti, and then it's will over. It's will over, right? So let me tell you, spirane. Now, I will make a spirane from this only. I will make a spirane from this only. Just see, spirane. Pi in spiranes. So if I say I'm having one carbon, so second carbon, third carbon, fourth carbon. And if I say, if I place here hydrogen and place here chlorine, same thing. If I say this is on bed, hydrogen is on bed, then means horizontal. I will say it is horizontal, right? Chlorine going away, but it is also on bed, horizontal, horizontal. Now, if I draw the ring, if I draw one ring, then it will be vertical. It will be vertical. You know, tetrahedral. More you visualize tetrahedral, if I say this is one V and this is another V, this is another V, this is only tetrahedral. Can you see this is tetrahedral? Two V's are bisecting each other. So I would like to say that if this is V, then this V will be vertically, this ring will be vertical, cyclobutane ring vertical. If this is vertical, then another ring will be horizontal, horizontal. And this is horizontal, then another ring once again vertical. And if this ring is vertical, just see, let me write down. Let me write down. This is horizontal ring. So this is vertical ring. This is vertical ring. horizontal ring. So this is also horizontal ring. So what? Sorry, I have written wrong. What I have written wrong. It is horizontal. So this is vertical. Okay, kids. This is vertical. This one is also vertical. And this one is horizontal. And then this sigma bond once again will come vertical, horizontal only. Will come horizontal only. So if I say this is hydrogen and this is chlorine, so both the two hydrogens horizontal and same side, right? So on the same plane. So the rings must be odd. There the pi bonds must be odd. Here rings must be odd. And these two should be different. These two should be different. And they should be different. These must be different. They should be different. And rings must be odd. God. Rings must be. This much is clear to each and every one of you kids who let me know. Till now it's clear. Only then I have to tell you, only I will take 5 minutes more. Can I take 5 minutes more, kids? Wow, Bhavani, thank you. Priya Pathak, thank you. Thank you. Really, kids, you are most dedicated students. Most dedicated. I have no words, kids. You kids are really most dedicated. Yeah, Sahana. I said vertical, but written horizontal and said horizontal and written vertical. It's now the last one. Last but not the least. Ready, kids? See, I'm completing each and everything, isn't it, kids? I'm not leaving even a single thing. I'm teaching you from the very scratch and taking you up to the highest level. Whatever the NT is going to ask, I will not leave in a single stone to be unturned. Okay, Pinvinda, thank you, kids. See, sin and anti. Sin and anti. See, this is I'm going to deal with oximes, oximes, oximes. But before I we are not having that much of time, otherwise I would have given questions. But see, it's oximes of aldehyde. Suppose if I say what is actually oxime, let me tell you. First of all, this is acetaldehyde. And if we react acetaldehyde with hydroxylamine, hydroxylamine, this is acetaldehyde. And once they are going to react, water will get eliminated out, and you will get compound like this, CH3, CH double bond NOH. This, you can say acetaldoxil. Either you can call it acetaldoxil, or you can call it oxime of acetaldehyde. Now it will exist in two forms. It will exist in two forms. Let's see what are these two forms, kids. First, it will exist like this. And another form is these are two forms. See, what is the difference in between two forms? Let's see. In this form, this hydrogen and OH, they are on same side. We will say syn acetaldoxime. What we will say? We will say syn acetaldoxime. And this, the hydrogen and OH are opposite. We will say anti-acetaldoxime. Now kids, from this you will start thinking like that, ketones, oxime will show GI or not. Definitely you will start thinking like ketones will show or not. Thank you, Priya. Thank you. Ketones, GI will show this or not. So see, let me tell you, this is going to be the last one, but not the least one, kids. Oxime in ketones will show GI or not. Let's see. If I say that acetophenone is CH3, B6H5, what you have drawn. This is acetophenone, you know. And if I'm reacting with hydroxylamine, water will eliminate out, and we will get compound like this. Two forms I will get. One form this, and another form like this. Now try to understand. How will you write its GI? Just see. I would like to say that OH is on the same side of phenyl, so I can write then with respect to phenyl. Its name I can write like this, or anti opposite to this with respect to methyl. Two names for this I can write. For this also I can write two names. Methyl and OH same side. So syn with respect to methyl, or I can say OH is opposite to phenyl, anti with respect to phenyl. That's it, kid. That's it. Got it. I want to see that everyone is able to understand or not, kids. Do let me know. Oh, Priya Pathak ji, thank you. Really thanks. Kids, do let me know. I want to say in the chat, everyone, everyone, do let me know, kids. Fast, kids, fast. Do let me know. Do let me know, kids. बहुत बहुत धन्यवाद everyone. Wow, Pinmin bhai and everyone, kids. Do let me know. You really enjoyed it. I'm Cden. I'm from Manipur. So, Magdan, you're really liking Harni Singh. You are new to this class. Thank you. Thank you. Mandy, thank you. Thank you. Jyoti, if you want to see senior most, then you are going for E and Z. This is sin and anti. If you want to see E and Z, you can go with like that also. See, this is senior and this is bond. So this is Z configuration. Z configuration. Here this is senior, that is bond senior. So E configuration. You can write like this also. You could have gone like this also. Now kids, Jyoti, is it clear? Now kids, I would like to say once again to every one of you that apply code HSP10, share it to maximum people. Code is HSP10. If you apply this code, you will get the batch, any batch, whatever batch you want to join in Hindi, in English, or in English. Any teacher, the best teacher of Unacademy kids, you will get the batch just for rupees 4,999, which is available for. Means if you join offline, they will charge 1 lakh rupee, 1.5 lakh rupees. Too much amount they are going to charge, but here it is available just for rupees. If you go for plus 4,999, and if you go for iconic, just 13,999 kits. Will you share it to everyone? It's your duty. If you're sharing it, you're caring for others, and Almighty God is definitely going to help you a lot, kids. Your friends, your relatives, those actually who wants to get such type of quality lectures from the best teachers of this world. If you are interested to apply this code HSP10, you will get my mentorship and the batch access. You can switch the teacher if you're not able to understand. Number of switches are allowed, and that too free of cost, kids. When you share it to everyone, and one more thing is over there, kids. This, what is this? I don't know. See, kids, who is coming over here? What's the magic is going to happen? August 23 at 7 p.m. Notify me. Who is this? ये कौन सा Pokemon है? Hey, ये कौन चित्रकार है? The who is over there? Who is this Pokemon? Which Pokemon is this? So stay tuned. Okay, will you share it to others, kids? Let me see the chat. What chat is going on? Magical teacher, very good, very good. In this batch, super easy. Wow, Pinminba, love from Manipur, Magden. Everyone, thank you. Gela Uday Kungar, Priya Kapatak, and everyone. Bye, kids. Bye. Bye. Yeah, Priya, definitely. I will try my level best. Sure, for sure. Bye to all of you kids. God bless you. Love you kids. Bye bye. Good night. Shubh Ratri, Shabakar. Dhanyavad Alu. Bye bye kids. Bye.